Welcome back to the night class. Today we're going over the Chapter 6 review in Honors Algebra 1. Smart kids. All right, so if you have any questions, stop me. And if it's something that you wrote different or you got something different at all, let me know. If you're good, give me a thumbs up and we'll keep rolling along. All right, so number one, we had to write the expression 9x to the 9/10 in radical form. Now, understand a radical is just that little sign, okay? That radical can mean a square root, it can mean a cubed root, it can mean a fourth root, it can mean whatever root it is, but the little check mark thing is the radical, okay? So, what is being taken to the 9/10 power there? Incorrect.
No x.
Just x. It would have to have a parentheses around it like that for everything to be going to the 9/10 power. Does everybody understand that? Okay? So, it's just the x. So, the 9 stays 9. And then we take whatever the denominator is, that's the root you're taking. So, we're taking the 10th root of x to the 9th power. That's all there is to it. Okay? That is radical form. This is called exponent form, okay, or exponential form. Number two, it's reversing. They give it to you in radical form, and they want it using rational exponents. So, what's my base? 4, and it's going to what power? Negative 9/8 power. Okay. Any questions on 1 and 2? Easy peasy. Moving on. Number 3. We have like bases. Everybody agree? So my exponents need to be the same. If we're multiplying like bases, what do we do with the exponents? We add the exponents. So we're going to have x over 5 plus x over 4 should equal what? 2. The exponent on the other side. And we work that out. Now you can put it in your calculator if you want to. 1/5 plus 1/4, okay? Here's how I always do it. The bottom number, you multiply them, okay? So that will just be 20. The 4 goes over here, and the 5 goes over here. So that's 4x plus 5x. Needs to equal 20. Not 20, excuse me. 2. Sorry about that. And then you work it. Multiply both sides by what? Multiply both sides by 20. We end up with 9x equals 40. Divide by 9, and how did they, I guess they just left the answer like that. If you put a decimal, that's okay too. 40 over 9. Everybody good?
Yes.
Okay, yes ma'am.
When you got x over 5 plus x over 4 equals 2, did you get the 2 from the square of
Yes,
3? Okay.
that's all your exponents. Okay? Because again, once the bases are the same, now we can say the exponents are the same. Okay? Number 4, same type problem, just a little different. Are the bases the same? No, but we can make them the same. 6 to what power gives me? Third power? All right, so 6 to the 3rd power to the x minus 3 equals 6 to the 2x plus 1. Everybody see how I did that? Okay? Now my bases are the same. Now I can set my exponents equal to each other. A power to another power, what do we do with the exponents? Multiply. So this was 3 times x minus 3 has to equal 2x plus 1. And we distribute that out. 3 times x is 3x. 3 times negative 3 is negative 9. Equals 2x plus 1. Subtract our 2x over. We get x. Add our 9 over. We get 10. Okay? Number 4 is 10. We get it right? Yes. That's what it has on the answer sheet. So, everybody good? Okay. Number 5 says draw a sketch of f of x equals 4 to the x and use it to answer the question. What is the asymptote for f of x equals 4 to the x power? So, the sketch does not have to be very precise. Okay? It's just a little sketch, literally what it says. So how do we make a little sketch? What do we need to make? We do it every time we're graphing a table. Okay? Every time we make do graphs, we're going to make a table. I always start with whatever makes the exponent what? 0. So in this case, we'll have 0. What is 4 to the 0 power? 1. And we go left of 0 and right of 0. Do you have to use every point? No, you do not have to use every point. If it's too big, don't use it. If it's too small, don't use it. Okay? What is 4 to the negative 1 power? 1/4 or 0.25, right? What is 4 to the negative 2 power? Not 1/8. It's 1/16. And I don't know what that is as a decimal, so you can look it up if you want to. Yeah. I'm just going from my 0, left and right. I have 1 and 2 right there. You need to do some on either side of it to make sure you know which way it's going. Okay? If you plug in 1, you get 4, and if you plug in 2, you get 16. I'm not going to graph 16. Okay? It's just too big. So, our little sketch, we're going to have 0, 1, negative 1, 1/4, negative 2, 1/16, and you can kind of see 1 is up here at 4. My sketch should look something like that. Make sure I don't cross my x-axis, right? Now, according to the sketch, what is my asymptote? Y equals 0. Very good. Okay? It's not going to cross that. I also do not mind if you put it in your calculator and look at that graph as well, just to make sure you graphed it right. Okay? Everybody good? Moving on. Number 6. Write an exponential function for each set of points. All right. So, y equals ab to the x. That's an exponential function, right? I guess technically, since it said function, I guess they want it in function notation. Just know I'll take it either way, okay? It could be f of x equals ab to the x. But if you want to put y, that's okay too. Doesn't matter to me, all right? So f of x equals a is my initial value, correct? What is my initial value? 25. B is my common ratio. So what are they multiplying by to get the next number? 2. 25 times 2 is 50. 50 times 2 is 100. 100 times 2 is 200, right? So that's your B. And then to the x power. All there is to it. Everybody good on 6? Okay? So we got 1 through 6. We all going to get right. Right? Awesome. Number 7 says, does the table represent a linear or exponential function? Remember, if it's linear, the y's will be being added or subtracted to get the next number. If it's exponential, we're going to be multiplying to get the next number. Okay, so what about 7? What's happening? They're adding how much? 5. So that is definitely linear. And what about 8? It is exponential. Exponential.
I was confused why that one didn't have a
I'm not really sure why it didn't have a choice. It just didn't. That one's a short answer one. Okay? But it's the same question. Yeah, I mean, it doesn't really matter. Number 9 is the same type of question. Does the rule represent a linear or a exponential function? Well, What does that look like? Exponential. It's always exponential if your variable is the what? Is the exponent. Okay? If your variable is the exponent, if your variable is the exponent, it is exponential. Makes it pretty easy, I think. Okay? 10, 11, and 12.
Yeah,
I noticed as I was walking around yesterday that some of us were having a little bit of problem with this. Okay? So, yes, sir.
I just gotta say, so when you work out 11 and you work out 12 on the answer key, they never round up when you're supposed to. Since it's a real world problem, shouldn't you round up?
Well, I don't know. Let's see what it's talking about.
People.
All right. So 10. Same thing, okay? I want y'all to understand, we're still doing y equals a times b to the x, but now since we're talking about money, okay, and we're talking about percents, okay, how much of a percent is it increasing? Our b is going to change to 1 plus r to the x or 1 minus r to the x, depending on what the rate is. Does everybody understand that, okay? So same formula. You still got A out front. It's just now your B, you got to figure out your B. Everybody with me? Okay? So this is going to be Y equals 19,750 would be your A, times, it says it depreciates. Ooh, that's a big English word right there. What does depreciate mean? It goes down. It decreases in value. So we are going to say 1 what? Minus 0.13 to the x power, which is in this case, I'm sorry?
Can't you just put 0.87?
You sure can. Yes. If you put 0.87, that is 1 minus 1.13. Okay?
Okay, what about the y equals? Like, is it like a don't put that.
What about the y equals?
Yeah, like don't put y.
That's okay.
Because like I did it like 2000 equals and then it was the actual answer.
That's fine. You don't have to put, like, the answer sheet doesn't even have y equals. Okay? So, you just stick this in your calculator. Hopefully, you got out 5,639.50.
Yes, that's right.
Okay? So that's how much money that's how much the tractor would be worth after 9 years. Okay? That's the bad thing about cars and tractors and go-karts and anything, iPhones, okay? If you buy a car, as soon as you drive it off the lot, you've just lost money. Okay? Housing, land, it's different. Okay? Houses and land usually always go up in value. Okay? Unless you have a flood or something. But so when people invest money, a lot of times they invest it in real estate. Okay? They don't invest it in cars because, like I said, as soon as you buy a new car, you drive it off the lot, guess what it's not anymore? It's not a new car anymore. It's now a used car, and it just lost a bunch of money of how much it's worth. Okay? All right? 11. Suppose that the population of deer in a state is 13,500 and is growing 3% each year. Predict the population after 11 years. So, same process. Y equals, we have how much to begin with? 13,500. We are growing by 3%, so that's 1 plus 0.03. And to the what power? 11 years, okay? Make sure you don't put 0.3. 0.3 is 30%, okay? 0.03 is 3%. Is that you put 0.3?
It took us forever.
It happens. So my answer says about 18,687 deer. Okay? And I'm assuming they rounded down, right? Which when I said that the other day, I was really talking about if you're buying something. Okay? So we're not buying the deer. We're just talking about how many there are. Okay? So it doesn't, I guess they rounded down because they were just doing a true rounding. Okay? But what I was talking about, like if you're going and you're trying to figure out how much fertilizer to buy to fertilize your yard, and you figure out, well, I need 3.2 bags of fertilizer. Well, Lowe's isn't going to sell you 0.2 of a bag of fertilizer. You're going to have to buy 4 bags of fertilizer. It's a different type of question. Is that making sense? Okay, this is just asking how many deer there are. Well, there's about 18,687. If you put 18,688, I'm probably going to give you the right answer. Because, again, we're talking about. Okay? So 687, 688, it's about the same thing. Okay? Yes, ma'am.
Are you going to count off if we don't do the about?
No, ma'am. No, ma'am. Any questions? Does that answer your question about why the rounding part? Okay. Here, suppose the population of a town is growing 2% each year. Predict the population after 8 years. Please understand, these are all the same problem. We're interchanging deer with people. Okay, instead of growing 3%, they're growing 2% this time. But it's the same thing. So y equals 12,200 times 1. Are we growing or decaying? Growing, so 1 plus 0.02 to the 8th power. Okay, and that is, according to my answers, 14,294. Is that what everybody got?
Yes.
Okay, and that was people. But you don't have to say people if you want. Everybody good on page 1?
Yes.
Awesome. Wonderful. Page 2. Find the balance in the account. All right. So now our formula is changing just a little bit. Because now it can be what? Compounded. Okay? So I want you to understand, we've gone from y equals ab to the x power, all right? And then they started giving us, hey, it's going up by 13%, going down by 13%. So that changed it to 1 plus r to the x power, okay? And now we're getting compounded. So now we change this just a little more. It's 1 plus r over n and n to the x, okay? So you add an n there and an n there. N is how many times you're compounding it. Does everybody understand that? Okay? So one more time. This one you're compounding it annually. Well, that just means you compound it what? Once. Okay? So really, I could actually use this equation for that one. That make sense? Okay? Use this equation for that one, you'll be okay. Because n is 1. So what is r divided by 1? R. Okay? And what's 1 times x? X. So it doesn't matter on this one. Okay? So we're going to have, let's see here, our amount is, our principal is 3,100 times 1.05 to the 6th power. How much money we going to get there? $4,154.30. All right. It's a good amount. It's really not, but we made about $1,000 in 6 years. That's not too bad. Okay, it's better than losing $1,000 in 6 years. 14 and 15. We have to use the compounded ones. Okay, so we've got. I'm gonna put 14 over here so I have a little more room. 14, how much is our principal? 5,000? So 5,000 times 1 plus, what is it, 0.01 over. How many times are we compounding it? What does semi-annually mean? Twice. Okay? Twice. If it said monthly, what would that be? 12. If it said weekly, what would that be? 52. There's 52 weeks in a year. Okay? If it says daily, 365, okay? So we got, excuse me, 2 times, or divided by 2 to the 2 times 32 years, so 32. Put all that in your calculator. My answers said you should get $6,880.15. Is that what your calculator said? Don't say sure. That makes me think you didn't put it in there.
I was like 3,000 off because I did the other one.
You used the wrong. You didn't do the compounded? Gotcha.
I got that. That's a problem. I got it right.
I didn't get that. I got 6,800.
You typed in 23 instead of 32 for the years. Did you get that?
I got that.
Okay.
I was right.
Be careful with. I do that all the time too, Daisy. So don't worry. Slight case of dyslexia. Yeah. Just with numbers though.
I just got.
I do it with everything.
Do you do it with everything? 15.
Not gonna lie, I only made $2,000 after 32 years. I do a little bit more.
Yeah, that's not much. That's about
Well, my equation is also like.
That's not much. But why was it just that much? Because what was the interest rate?
1%.
1%. That's not a lot. Now, the great thing about 1% is it's a lot if you're talking about $1 million to start off with.
Yeah, but we ain't
Okay.
rich.
Speak for yourself. I teach school. Money is no option for me, okay? I don't know about you heard about teacher salaries, but they're pretty awesome, okay?
Yeah,
Just saying.
like skyrocket.
Like, we buy Jif peanut butter or Peter Pan.
Oh, you rich.
Or Peter Pan.
You rich.
Either one. Yes, exactly. There's some things you don't skimp on, okay? Peanut butter and ketchup are two of the things. You either get Hunt's or Heinz. Don't be going Del Monte or whatever. Okay? It's just saying. Hunt's or Heinz. All right. I don't know. I'm very, 15. How much are we starting with? 1,600 times 1 plus. What's my interest rate this time? 3.5. So that's 0.035. How many times are we compounding it?
4.
Quarterly. So that's how many times in a year? 4 times. So 4. And then 4 times how many years? 3 years. How about that?
That's fantastic.
That's not bad. All right, so plug that in. You should get 1,776. It's the year our nation was born. And 33 cents. That was 1492. Columbus sailed the ocean blue.
Do me a favor, where'd you get that 4 from?
Quarterly. Compounded quarterly. Okay, quarterly means 4. It will be. Oh, no, the test will be, yeah. Yeah.
Wait, the test is online?
No,
I was fixing to say you're killing me.
I don't mean to. No, the test is going to look like that. Okay? All right? All right, everybody go with 14, 15?
I am now.
16, write the explicit formula for the geometric sequence. So, explicit formula is,
I couldn't remember what it was.
it's what you've been doing the whole time.
I can't remember. I didn't know what it was. I just had it.
This is the explicit formula with one little extra thing. It's not x, it's x what?
N minus 1.
Well, n or n minus 1, but I use x too. It's x minus 1. You just got to make sure you put the minus 1. Okay?
What's the recursive?
That's only for the geometric sequences, and I'll do my best to explain why that is when I write this, okay? We're going to get there. So, explicit will be y equals, what's A1? -3. My R or my B, what are we doing? Multiplying by -2. to the x minus 1 power. Okay? Now, they have a sub n equals negative 3 times negative 2 to the n minus 1 power. I'll take either one. They both mean the same thing. Okay?
How did you get A? How did you get A?
Negative 2 is what are they multiplying by to get the next number? Okay? All right. Now, on all of them until now, our variable's just been x. Okay? Well, that's because when you're dealing with just normal, like what did you start with? Okay? So, for example, on these money problems, okay? Did we have to wait a year before we had $3,100? No. We have that now, okay? So if your x is 1, that means after how many years? After 1 year. Everybody understand that, okay? Because when you plug in 0, it makes the b 1, and you're left with what you have to start with, okay? Well, so basically on all these problems, you're starting out at 0, right? Okay? Well, when you're talking about a geometric sequence, you can't start at 0. You have to have a first number. Is that making sense? Okay? So that's why you have to include the x minus 1, because you can't start at 0. You have to start at what? At 1. And what's 1 minus 1? Now you're at 0. Does that make sense? Okay? Because we want this to count, we want this to go away. Because what's my first number? Negative 3. So negative 3 times what would give me negative 3? 1. Negative 3 times 0 would give me 0. Okay? So negative 3 times 1 would give me negative 3, the first number. So I have to plug in 1 here. 1 minus 1 would give me 0. That cancels out that, and now I have that as my first number. Okay? But just know, you only have to do the n minus 1s on the sequences. Okay? 17 and 18, you're just saying, is it geometric? And if so, identify the common ratio. So, is it geometric? And if it is, what are they multiplying by is basically what it's saying. So, what do you think? 17, yes or no?
Yes.
Yes?
-4.
And your common ratio is -4. They're multiplying by -4 every time. All right? How about 18?
No.
No. They multiplied by -2 first, and then they multiplied just by 4, and then they multiplied by I don't know what. So they're not multiplying by the same thing every time.
So, like, is that even any type of sequence?
That is not any type of sequence that I know of. No, ma'am. I guess it could be, let's see here. Well, there is a pattern. Let's see here. They're subtracting 6, right? Here, and then subtracting 10, and then they subtracted 20, or maybe there isn't a, I don't know. I don't know what the rule is, but no, it's not geometric, which is all we're worried about right now, okay? So, 19. All right. So the recursive formula. All this means is you're going to take the term in front of the term you're looking for and multiply it by whatever your r is, okay? So these are very easy to write. It gives a1, right? It's -2. And we have to figure out what is my r. What are we doing to get the next term? Multiplying by -5. Everybody see that? So a sub n is just -5 times the term in front of it. That's it.
Wait, that's your answer?
That's your answer. Remember I told y'all geometric equations are a lot quicker and easier than the arithmetic ones. Okay? All this means is if I want a sub 11, right? If I want the 11th term, I have to multiply a sub 11 minus 1, which would be which term? The 10th term times what? negative 5. That's all it's saying. If you want the 12th term, you got to multiply the 11th term by what? Negative 5. If you want the 20th term, you got to multiply the 19th term by what? Negative 5. Okay? All right? 15, what is the 5th term of the geometric sequence? They already gave us 3 of them, so we just need to do whatever they're doing 2 more times. So what are they multiplying by every time? 4. So times 4, 320, times 4,
28.
that's it. That's the joke. That's it. That's the joke. Everybody good? Hot dog in a bun. What? I don't know. Did I tell you the time that my dad and me were riding down the road and we got passed by this ambulance? And when it passed us, like the back door was open and a cooler fell out, like one of those little, hand coolers. And they kept going because they didn't know. Well, that's what we were thinking. We're like, oh, it's like a kidney or something. But we opened it up, and it's ice, of course, but it had a big toe.
Is that a real story?
Yeah, it's a real story. Really happened.
Please tell me you returned the toes.
No, we didn't have time because we were in a hurry, so we just called a tow truck.
I just got it.
All right. Back to math. That was your joke of the day. Okay. Write the explicit formula for the geometric sequence. Find the 5th term in the sequence. So, explicit formulas are easier one, I think. Okay. We need A and our B, so A sub n equals. What is the first term? Lainey, it was hilarious, okay? Yes, it was. All right, what's A sub 1? Negative 4 here. Let me write it down here, okay? A1 times R to the n minus 1. That's the formula. So A1 is negative 4. R is, what do they multiply by every time? Negative 2 to the n minus 1. So there's my explicit formula, okay?
Is that a comma or a 1?
Here, that's a 1. That's A1. Okay? It's not a comma. And now what do we need to plug in for n to get the 5th term? 5. So, negative 4 times negative 2 to the 5 minus 1 power. Stick that in your calculator, and you get...
Wait, oh, the 5th term, never mind.
I don't know why I wrote down 16.
60.
It should be 64. Negative 64. Okay? You could have also just multiplied negative 16 times negative 2 and multiplied that answer times negative 2 and got your 5th term. Okay? But I think they're kind of wanting us to use the formula. All right? Everybody good? All right.
It's making sense to...
Yay. Good day. 22.
That's because it's Friday.
It gives you the formula. It gives you the initial value. And it describes a geometric sequence. Use the explicit formula to determine the 6th term of the sequence round to the nearest hundredth. Okay, so make sure you follow directions. So the explicit would be A sub, which one are we looking for?
The 6.
A sub 6 equals the first term, which is? That's incorrect. 3,400 is the initial value, times, what's our rate? 0.96 to the 6 minus 1 power. Okay? And so that's 3,400 times 0.96 to the 5th power. What do you get?
2,770.
We round to the hundredth. Okay, so 2 decimal places. Is everybody understanding that?
Yes.
Why is that not A1 on this one? Because it's, what form is this? That's the recursive, okay, form, okay? That's why it says use the what? Explicit formula. So we had to write it in the explicit formula to get the answer, okay? Now, is that the only way you could have done it? No, okay? You could have said 3,400 times 0.96, multiplied that times 0.96, multiplied that times 0.96 until you got to the 6th term, okay? But it sure is quicker just doing it all in one, okay? 23, write the geometric sequence as a function, okay? So f of n, f of x, it doesn't matter. What form is this that they gave us? That is the recursive, so they want the explicit. So we need to put what first? A1, which is 32, times, what are we multiplying it by every time? 3 out of 13 to the n minus 1 power. That's all you had to do because it just said write the sequence, okay, as a function. So there's your function. Like I said, if you used f of x, that's great too. Everybody good? 24, we're doing the same thing. They just give us information differently. But it's the same thing, write a function. So f of, I'm going to use x this time just to show you it doesn't matter. Okay, f of x equals, what's my initial value? Negative 3 times, what's my ratio? To the, well, in my case, it's what? X minus 1 power. Okay? The only way you can get this wrong is if you use x in one spot and n in the other. Okay? That's not the only way. That's not the only way, but that's one way. Okay? If you use x here, make sure you use x there. If you use n there, make sure you use n there. You can use a c or z, yeah. It doesn't, as long as they're the same. Okay? All right. 25, you literally just have to say exponential growth or decay, and then you have to tell me what is the rate of change. Okay? So, yes, sir.
I just want to.
Oh, you want to ask? Okay, so is that growth or decay?
That's decay.
That is definitely decay. How do you get the percent? How much?
55%, right?
That is, it is 55%. How much less than 1 is 0.45?
You would say that's like instead
Okay.
of putting the 1 minus.
Right.
that-
They've already done, basically this is what's happening. They're saying 1 minus r equals 0.45. Okay? And so you can subtract 1, negative r equals negative 0.55, and then divide by your negative makes it positive. But really, and the k one is really the only one you kind of really got to think about, okay? You got to think how much less than 1 is it, okay? And just in case it happens, I don't, like I said, I don't remember what's on the test. It could be, a lot of people miss something like, let's say it looks like this. Exact same, but it's, let's say, something outrageous like that, okay? That obviously is what?
Growth.
Growth. But what's the rate? Change it. That's the decimal rate. That would be growth. Growth. 260%. Okay? There is a such thing as 260%. You got me? Okay, so don't, like I said, I don't know that happens. I'm just saying it just in case. Well, in this case, we say that minus 1. In this case, you say 1 minus the number. If it's bigger than 1, you subtract 1 from it. If it's smaller than 1, you subtract that number from 1. Okay? You can do it. All right?
Can you write it down?
Can you write it down? Sure, you write it down. No, I'm not going to write it.
Can we use a review on the
No.
This is the test.
What about this one?
It's
Growth or decay?
10%.
Growth.
It's growth.
It is growth. All right. So, how much more than 1 is that?
10.
It is 1/10. Okay. Which equals
10%.
10%. They want it as a percent.
Oh, wait, whoa. Okay, that makes sense.
Okay. 11 over 10 minus 1 would be 1/10. So changes to 10%. All right. These last two, you're doing the same thing. You don't have to tell me the rate this time, but they are a little different. So this one, it's not to the t power, it's to the t over 2 power. We got to get rid of that part. Okay, so I'm going to rewrite it by moving that 1/2 power to the inside. Because remember, a power to a power, what do you do with them? You multiply them anyway, so 1/2 to the t power is t over 2. That makes sense. You take the 1.3 to the 1/2 power and stick it in your calculator.
It's about
So what is 1.3 to the 1/2 power?
1.14.
That's good. Okay? Is that a growth or a decay?
Growth.
That is growth. That's all you're doing there.
I have no clue what this
I put this in my calculator. It gives you that. Is that number more than 1 or less than 1? So it's growth.
Okay.
But before you can do that, you've got to get the t by itself out there as an exponent. You understand? So here, this is going to equal 3, 1.05 to what power? To the 9th power on the inside, t on the outside. So what is 1.05 to the 9th power?
So basically, you're telling me you just scooch that on the inside?
You just scooch it to the inside. That's a great word.
Scooch it.
What is 1.05 to the 9th? 1.55? All right.
Lanny, you find the word scooch.
So, is that growth or decay? That is also growth. It's greater than 1 still.
The whole time, all of yours is growth.
Okay?
And the other tests.
On the practice test? You've already done.
Yeah, I finished practice.
Any questions?
I did this yesterday.
No need to
Yes,
work
ma'am.
ahead. I'll just.
Oh, you're giving me that. All right, you out there in online land, all my favorite mathletes, have a great day. Stay above the line.